Hello everyone, welcome to Find Academy. I am Kevin Karya. Today we're going to be solving top k frequent elements on Leetcode in Python. So we're going to first understand the question, then we're going to visualize the approach and understand it, and then we're going to be coding the approach. So let's get started with that. So let's start reading the question. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. So basically, here if we take this example, we've got 1 which appears 3 times, we've got 2 which appears 2 times, and we've got 3 which appears once, right? And now the value of k is 2, so we need to give the top k, or in this example top 2 elements which occur the most number of times inside the entire array. So over here it's convenient that conveniently this is arranged in descending order, so we can just pick these two and return this as the answer. So 1 comma 2 is given back as the list of results, right? Now the approach for solving this question is we're going to be using the bucket sort method, the bucket sort algorithm, to solve this question. Now if you don't know what bucket sort basically does is, let me just visualize it for you. So let's take an example. Let's take 1 1 2 2 5 5 8 8, right? And like a 9. All right, now what bucket sort will do is it will create a long array, right? And it will be like a table, right? Let's visualize it like a table where you will have 1 2 3 4 5 6 7 8 9, right? And now what will happen is that for each number you'll be storing the count in it, right? So we'll first take 1, and 1 appears twice, 2 appears twice, 3 appears 0 times, 4 0 times twice, 0 0 2 1. And through this, if the top if let's say k equals to 4 was given to us, we could have picked these 4 and returned them as the answer. However, the problem with bucket sort is, with this method, is that first of all this will take us a lot of time, so it will take like n log n, I believe, right? And on top of that, since we have no particular way of making out that where our most frequent elements are present, we'll have to iterate through this entire array. So that will be again k times, right? We'll have to go through this. I mean, we need to find top 4, right? So we'll just go through this. We'll have to maybe sort this, and this will be a lot more complex. So now what we'll be doing is we'll be adapting another way of bucket sort, which is a smarter approach. And let me just show it to you. So when we created this example right here, it was the values and their counts, and these were stored in a table, right? These are stored in a table. Now this time what we're going to be doing is we are going to be storing the counts here and a list of values. So basically what we'll do is, another problem with this method was that in the example that I gave you, right, 1 1 1 2 2 8 8 and then 9, right? We had no specific way through which we had a limited number of the length of this bucket, this entire array was not limited, right? And there was no way we could find that out. So instead of doing that, that would also cause problems, and that would also not give us a good time complexity. So that's why what now we'll be doing is we'll be storing counts over here, right? And then for each count, so basically 0 times, 1 times, 2 times, 3 times, 4 times. And now if we take this array as our example, right, we have 1 2 3 4 5 6 and 7 elements, right? So we'll just do 5 6 and then 7 over here, right? So now in this manner what would happen is that we'll go through this entire array and store all the numbers which appear 0 times, which appear once. So once will have 9 appears once, right? And now let's assume, for the sake of simplicity, that let me just edit this array a little bit. Let's get rid of wait, let's just rearrange this. Let's do 1 1 1 2 3 3 and then 3 again, right? No, so let's make this 3 and 4, correct? Now in this case what will happen is 2 appears once, right? So we'll just put, let me just change the color, right? We'll just put 2 over here. 3 appears twice, so this will contain 3, and 4 appears once again, so this actually will be 2 comma 4, right? This will be like this, and then 1 appears thrice, so this list will contain 1 and these will just be empty, right? And let's assume if over here, when I was creating the example, instead of 4 I would have given 3 over here, then again we would have lost the 4 over here, right? And instead of 3 over here, what would have happened is that we would have just have 2, and then 3 and 1 would be over here, so 1 comma 3, and then this would have closed up, and then this would have gone away, right? So that's how we're going to be approaching this problem. And now the best part about this problem is that the length of this entire storage array will be, or list will be, uh, n plus 1, right? So the length of this input array plus 1, because over here we have 7 numbers, so this has a length of 8, so n plus 1 will be the size of this entire array, right? I should not put that over here. And also when we are now trying to find the top k elements, what we'll be doing is we'll be going in a descending order. So we'll first go to 7. Do we have anything for 7? No. Do we have anything for 6? No. 5 4 3. So now over 3, let's say if in the question k equals to 2 was given, we found 2 over here, so we use those 2, we again checked that how many values, so we just create a result, right? And we'll append 3 to it, then we'll append 1 to it, and then we'll come over here, and when we are over here we'll check if we need more numbers, and if the length of results is equal to k, then we'll stop, correct? Now, and basically in this approach, also the time complexity, so basically once we create this, when we are scanning this, it will be O of n, because we're just going through this entire thing, right? So that really will be linear time, and that is something that will that is ideal, right? So while putting this up, again it's O of n, and even while scanning it for k, it's O of n, so O of n plus O of n is basically O of n, correct? So it's a linear time solution to this. So now let's head over to the implementation. So for coding this, we're going to start by creating a hash map, which will basically store the values, right? The counts of each value. So basically, let's just write a command: hash map, creating hash map, creating hash map to store counts of each value, right? And that is going to be called a hash map, right? And then we're going to just create it as an empty dictionary, because that's how hash maps work in Python. Now we're going to be creating this table, right? This table. So table, creating table to store the list of values with the same count, right? So table equals to, and it's going to be a 2D list, right? So list, the first list, and then an empty list, because we're initializing it, for I in range length of nums, right? Length of nums plus 1. And why did we do that? So basically this has 6 elements in it, right? We have 6 elements over here, and the length of this table is supposed to be plus 1, right? So in this example we had 7, and the length of this was 7, but like 8 was the length, because indexing starts from 0. So basically we have to iterate uh, n plus 1 times and create an empty table, right? 0 is not of importance, but because Python works that way, we are doing it that way, right? And once this is done, we've created an empty table. Now what we need to do is we need to populate our hash map. So to populate the hash map, we'll just write here populating the hash map. We will be iterating through this nums, right? And every time we get the number, we'll be fetching the current value and appending to it. So we'll say for n in nums, uh, we're gonna fetch, so hash map bracket n, right? So we're gonna fetch, the key will be the number 1, 2 and 3, and the value will be the count, right? So we're gonna be this 1, we're gonna add 1 every time we come across a number. We're gonna fetch the existing value for that number, we're gonna fetch the count of that number, and then we're gonna add 1 to it because we have come across it. And then we're gonna do hash map dot get, and we're gonna write n over here. And in case if currently if there is no key for n, if there is no key for n, we'll return 0, right? So now we have gotten the hash map populated. Now since we have the hash map, now we have to go through the hash map and we have to populate the table, right? So populating the table, and now what we're going to be doing is we are again gonna make a for loop. So for and yeah, this time what we're going to do is we're going to do the function known as hash map dot items, and what this will return is it will return a list of tuples with the keys and values. So basically over here, since we have the count, and if we take this example, we'll have 1 comma 3, 2 comma 2 and 3 comma 1, and it will come as a list. So for n comma c, right? So this is for num comma count. Let me simplify it for you. For num comma count in hash map dot items, right? And if you want to just check this, we'll just print num, we'll just print count, and we'll just print hyphen hyphen. And if I run this, we'll get the output. Obviously, this is going to fail because we still haven't given the answer yet. But you can see the output over here. Oh, we have made a spell over. And yeah, if we run this, see what 1 comma 3, 2 comma 2, 3 comma 1, right? As I told you before. So like this works, right? And now we're gonna take num. So in the table, we're gonna be fetching the count, right? We're gonna be fetching the count, and then we're gonna be we're gonna be appending the num to the empty list, right? So right now what we have with us over here, right now we have created let me just erase this, or I'll just make this over here, right? What do we have with us right now? We have the count, so we have 7 here, right? So 0 1 2 3 4 5 6 7, and all of these are just empty lists. All of them are empty lists because we have defined this here in table, right? All of these are empty lists. And now what we're going to do is in hashmap.items, since we got 1 comma 3 2 comma 2 and 3 comma 1, we're gonna take this 3, we're gonna take the count, we're gonna go to that specific count in the table, and then for 3, whatever list we have, we're gonna append the number to it, right? So let's just do that. For this, what we're gonna do is we're gonna go to table and we're gonna fetch count, right? And to that we're gonna be appending our number, right? And then what we're gonna do is we're gonna check if and yeah, or obviously we have to create a result, right? And actually result of, oh no, sorry, my bad. And now since we have our table ready, what we need to do is we need to perform this step. We need to loop through this entire table, we need to check for the value for each corresponding count, and then we need to append it to a empty array which will be calling result, right? So let's just say defining or creating an empty list to store our result, right? And let's just call this result and an empty list. And now we're gonna be iterating through the table to find the top k frequent elements. And now what we'll be doing is we're gonna enter into a for loop for I in range, and now this time we need to go to the length of the table, and like the length of table right now is 8 and the indices start from 0, so we have to start from 7, right? So range of length of a table, right? Length of table minus 1, right? Because the length of table is 8 and we need to start from 7, and then we'll go up till 0, and each time we'll be decreasing by 1, right? And once that is done, we are iterating through the entire table now, and now what we'll be doing is we'll be fetching, so table, and then in the bracket we'll be writing I, right? So now table of 7, and now this is a list, right? So for num, or let me just call this, yeah, actually value, let's call this val, for val in table of I, res result dot append val, right? And then we're going to be checking, so if uh, length of result is equals to k, then we have to return result. So what will happen is, each time what we will be doing is we'll start from here, from 7, right, from the last element. If there is any element present here, we'll add it to the list. Then we'll go, now then we'll check. Now if the value was 0 over here and we didn't have any number over here, we will first append the non-existing value here, and then we'll be checking. And now if there is no existing value, this for loop will never be triggered. But the moment we reach 3, we'll have 1 comma 3 present, and then we'll start iterating. So it will be, first we'll get the we'll get val as 1, and then we'll append 1 to the result, and then we'll check if the length of result is equals to k, then we'll return the result, or else we'll keep going. And since it is guaranteed that the answer is, there is always going to be an answer, we can return result here and we don't need to do anything else. So let's just run this once and let's check if we have not made any silly mistakes. And yeah, we have been accepted, and let's submit this code. And there you have it, we have got the solution accepted. So that's it for this video. Thank you so much for watching. My name is Kevin Karya. You can check out my website in the description below. Give us a like if you like this video, subscribe to the channel, and stay tuned.